There we go. So we can write it in different places, browser, Visual Studio Code, StudyLens, etc. We can also run it in different places, and we will see the difference later. The two main places where you can run it is in your browser, in Chrome or Edge or Firefox, or natively on your computer. For the next few weeks, we will only be running it in the browser. You don't have to worry about running it natively or whatever, but later when we are working on your group projects and writing servers, then we might also be running it on your computer without the browser. How do I hide this? How do I hide this? Oh, there we go. Okay, there is this fancy diagram. I'm sorry, I cannot raise the screen, so if you cannot see it here, please watch on Zoom. The goal of this diagram is to show you the relationship between the program we are writing, the computer who is running the program, and us as developers or future developers, and how they interact with each other. When we are writing code, actually, we are writing code for two people, not just for the computer, because the computer will have to run what we are writing, but also for our teammates. And when you get later and later in your career, actually writing for your teammates become more important than for the computer. Computer is very smart. It can read a lot of things. But when we are reading and writing code that someone else has written before, it's very hard to understand because we don't understand what they were thinking at that time. So when you're writing code, it's very important that you maybe use comments to explain what you are doing, that you use very clear variable names for what this variable is and what it's for, and that you format your code so that it's nice with white space in between and everyone can read it and not everything joined together in a small file. The computer doesn't care if all your code is on one line or if it's on 20 lines, it will read it perfectly fine. But if you put all your code on the same line, I cannot read it because I have to use my scroll bar and go to the right. And whereas if it's a nice document, I can read it. So keep in mind when you are writing code, your first reaction is, of course, yes, it works. But your second reaction should be, is this readable? Can I give this to a teammate and can they understand what's going on? And stuff like that. The computer, it runs your code from top to bottom. In JavaScript, it starts running a file and it just goes from top to bottom. And it will give you output. The output can be something is wrong. I could not read the file. There's a parser error. You made a typo. There's a symbol missing or a semicolon missing. It could give you a message that you wrote yourself, like console.log or something else, or it could give you no outputs. Maybe your program is doing something, but it has no outputs. Maybe your program prints something to the printer, and you don't notice anything on your screen, but you see something coming out of the printer. So the result of your program can have many outputs. Could be something that you see on your screen, could be changing a color of something on a web page, but it could also be something coming out of a printer or an email being sent or many different effects. That's so far for the diagram. And then let's show you some JavaScript and everything will be very clear. So the tool you see here, the black and white, is called StudyLenses. We will discuss later how you can install it and how you can use it to write your own. For now, we're just going to focus on the black part, so only the JavaScript code. And the first thing we're going to focus on are comments. Actually, they don't do anything. They are just for ourselves. The computer just ignores them. It doesn't read them. It doesn't care what's in there. And there are two ways we can write comments in JavaScript. The first one is with a start and an end comment symbol. So this is a start. Whatever you write in between will be comment. The computer just ignores it. You can write hello friends. Computer doesn't care, whatever you write there. And whenever you write this, the comment stops and everything outside of that is considered as code. If you don't want to write a whole block and you only want one line, you can write double slash and you get something like this. If you see here, this is JavaScript I'm writing. You see it has a different color. Most programs that you write code in, StudyLenses, Visual Studio Code, etc., will show a difference in color for many different things. Comments will be in one color, code will be another color. You even see a difference in color between the let and the test. I hear an echo. Okay. And hello also has a different color. So the computer is trying to help you to make the code even more readable. It's showing you like, hey, everything in green, I'm just going to ignore this because this is a comment. So use those colors, get used to them, because it's really helpful. Do we have any questions about comments? No? Okay. The next thing we have in JavaScript is something called a string. And a string is a type of variable or a data type, which you can use to work with text in programs. Of course, when we are writing a program, we will use text everywhere. We will use text to say hello to the user. We will use text to show something in a table. We will use text to send an email, to print a document. Text is everywhere. And so whenever you use text, we will use a string. A string in JavaScript, you can recognize it by everything that is inside quotation marks. Notice that there are two ways to do it, like this and like this. Both work. I think, and maybe you can correct me on this, the preferred way these days is to use single quotes. So while both work, we try to guide you in the direction that later in your career, everyone is using. So if you end up in a team, you're not the only one using double quotes and everyone else is using single quotes. But know that both are perfectly valid, both work perfectly fine. And maybe sometimes you will notice that it's actually easier to use double quotes than single quotes. Why is that? Well, you see it here, for example. We have a string here, and the string says, cow says moo. And inside the string, there are double quotes. And the string starts at the single quote, and it ends at the single quote. So everything in between is considered text. And the computer will not ignore it, but it will just say, this is text. I don't have to do anything else with it. So it will ignore these double quotes for special meaning. However, if I write this, do you see the problem already? My string starts at the double quotes, and it ends at the double quotes. And then the computer is confused, like, what is this piece of text here in the middle? It's not part of the string. And then again, here I start a new string and end a new string. So if I wanted to fix this, I could write like this, like you see above, or I could switch the quotes from here to single quotes. So whenever you start the string with one type of quote, single or double, you have to end it with the same type. Whatever you write in the middle doesn't really matter. But keep in mind, most people in the industry use single quotes, so we will try to use single quotes. I will not tell you, oh, you made a mistake, you wrote double quotes, but if you don't know which one to use single quotes. Any question about strings? Clear so far? Okay.
ABC like letter or character is it exists also, and how you make the difference between characters and string.
Okay. Two chapters. This is an example of a function. We don't have to understand what functions are yet. They work. We will see that in a later class. But for now, what you can remember is that if you use this part of code, console.log, we can write things to the output screen so we can read it. Actually, if I open my output screen, you can do it by pressing F12, or you can do it by doing right-click inspect element. I think you've used this before for HTML and CSS. Actually, one of them has a tab called console. So when, where's this button? I was looking for it Friday as well. Yes, there it is. So one of the tabs here is console, and whenever you write console.log in your JavaScript, and the JavaScript is executed, it will print to the screen, to the console. I can show you, if I press run here, we see that 4 things are printed to the console, 4 different lines. And if we look at the code, we see that there are 4 times console log. The first one prints an empty string. It has 0 characters, but it's still a string. It's still able to be printed, and it looks like this. The second one prints the word a string, exclamation mark, and we see it here. The third one prints causes mu, and the fourth one actually splits it with commas, sorry, but the output looks very similar to the other one. Why is this useful? Maybe later, if we want to log variables, you can put the name of the variable here instead of the string, but we can see that later. I'm sorry? Well, the log can be very useful for many cases. In normal websites, when I'm using a website, I will not open the screen. I will not look at the console logs. So console logs is mostly used for developers like us to help us figure out what's going right and what's going wrong. Maybe if you are writing a loop, something that runs multiple times, and if you write a console log, you can see what's going on in the loop without having to stop the loop every time or stuff like that. Maybe we will use a console log to print when something goes wrong. Let's say we want to talk to Google and send an email, but Google is not responding or Google is down. Then we can print in the console, could not send email because Google is down. And you might think, well, the user won't notice that, but then if we go to our own website and we try to send an email, we can open this and see what's going wrong. So it's a helpful tool. You will use it a lot to figure out what's going right, what's going wrong. And also in the beginning, when we are learning JavaScript, we will just use it to get some output from the program. Because you can write programs, but without output, it's very hard to see what they're doing. Any other questions regarding console log? So you don't have to know exactly how it works. Just know that you write console.log, open the brackets, and then inside you can place a string or later a variable. You close the brackets and then a semicolon. One comment about the semicolon: JavaScript is a language which is very flexible, liberal. You can make a lot of mistakes in JavaScript that other languages would not allow you to make. One of those mistakes is not writing a semicolon. If I run the code, JavaScript doesn't care. It's like, oh, new line. I will just assume there is a semicolon there. If you start writing other languages, which use semicolons like Java or C#, or they will say, burp, I don't know what this program is. There is no semicolon, please fix. JavaScript allows it. We will see later JavaScript is very flexible, sometimes maybe too flexible. But try to force yourself to write a semicolon. It's helpful not only for your colleagues, but also sometimes your program might run, but might do different things if you don't write a semicolon, because it adds 2 things together, or it doesn't work exactly like you expect. So even though it's not needed, please try to write it, because you will thank yourself later that you learned to write a semicolon every time. Of course, we can do more than just print a single string. We can actually add strings together. And in JavaScript, when we add strings together, we use the plus symbol. Just like adding numbers together. If you add 1 + 1 together, we add 2. If we add 2 strings together, we get the string stuck together like one word. I can show you in the run screen in the console as well. If we run this, we get hello, 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 hello. But you can see it's written in 4 different ways. So this string is split up in 4 different ways. Of course, this example looks very silly, but one useful case might be, my name is Jonathan, and you can write something like console.log hello plus name. And now if I run it, you see hello Jonathan. So this would be one way where you use the plus sign to add 2 strings together. One string is already there, and one string might be in a variable or something. We will get to variables in a second. Notice here, if you add a comma in console.log, it adds a space between the 2 strings. It's not very important. I don't think we use the comma in console.log very much, but you do? Yeah. Okay, I don't. But so that's a subtle difference, that if you log 2 different things to console log with a comma in between, it will add a space in there. So it's not exactly the same as a null. Any questions about adding strings together? Remember, use the plus sign to add two strings together. Sure. Okay. Hello? No, it's okay. When we write JavaScript, we want to write use strict. Is this still necessary in 2024?
I think the frameworks just add it and we don't put it ourselves there, but I think they do. Yeah.
Okay. Because JavaScript is so flexible, we try to make it slightly less flexible because otherwise it will do even more things that we don't want it to do. So one thing we do at the top of our files, write use strict. The JavaScript will see this and run in a slightly different mode, so it doesn't do so many crazy things. I think that's the best way to describe it without going too technical. But actually, you don't have to worry about it too much. When later when you're writing code, everything writes this automatically for you. So if you're writing React or other frameworks in JavaScript later, they will add this for you and you don't have to worry about it. Just know that when you see it, you know that it makes JavaScript slightly less flexible and prevents you from making more errors than needed. And now we get to the fun part. You see this use strict here at the top. You will see it on a lot of files. Variables. The best way you can describe a variable is it's a box. Just a box that you use at home to move when you're moving houses. And on that box, we put a label. Like this box is for the kitchen, this box is for the living room, this box is my clothes, etc. When we create a variable, we create a new box and we can put stuff inside this box. But first, when we create this box, we have to give it a name. We can use any name. There are a few rules about naming variables. For example, a variable cannot start with certain symbols. So when I do this, it says, probably if I hover over it, an identifier or keyword, which is the name of a variable, cannot immediately follow a numeric literal. It's actually not a very descriptive error, but no. Keep in mind, variables can contain many symbols, but there are certain limits. For example, you cannot start with a none. You can use underscores, but you cannot use dashes. Why? Because JavaScript would read this as a minus sign. Just like we have the plus sign, we have the minus sign. So we cannot make a variable called hello HYF because JavaScript would think that it says hello minus HY. But if we want to put two words together, which you use often in variable names, we typically use an underscore. Another way to combine two words together is to do it camel case, where you start lowercase and every new word you write uppercase. This is variable. So this is a way that programmers would use a variable with multiple words in it. Every new word starts with a capital and everything else is lowercase. Another way is like this. But you see it's much longer than the other one because you have all these underscores. In the industry, you will notice later when you are programming that this is the most preferred way. So if I have a variable and it's called list of students, you would write it like this. Yes, whenever you write a space, you see the color already changes and JavaScript thinks this is where your code ended, the name of your variable, and this is where the rest of your code starts. So we want to keep it as one word. Any other questions about variable names? Okay, so we have this box and we put a name on it. We can choose any name ourselves. Remember, we said in the beginning, I'm going to open the window because it's quite open here. Remember, we said in the beginning, we can choose any name. But we are writing code for our developers, even. So actually, we don't want to use a short name like X you see on the screen, because I don't know what X means. I can see that it's a variable, but what's inside? Is it your name? Is it your address? Is it your email address? I don't know. So remember that when you write a variable, you can write it like this. And the two lines I just wrote, they do exactly the same thing. I create a box. One box is called name, one box is called X, and I put the string Jonathan inside. The computer doesn't care which one I write, but my teammates care, because the first one is very clear. I'm making something to put a name inside. The second one could be anything. It's not very readable. One more thing, whenever we create a variable, we will use, for now, let. Let is telling the computer, hey, we want to create a new box. So it knows, okay, I'm going to create a box. The next word after let will be the name of the box. In a lot of tutorials online or even programs, you will see something different, and it will say var, which is short for variable. And it works exactly the same way. The result is this. They're the same. There's a very, very small difference, which I will maybe explain in 8 weeks because it's so small and so technical. But for now, you can know they're the same. However, var is old from the beginning days of JavaScript. Let is more modern, more new. So we learn you to use let. But it could be that online or in certain materials, you find code that is written with var. So I'm telling you that it exists. It's perfectly fine. There's nothing wrong with it. It's not broken. But we want to teach you the better new way. So we teach you let. I will not, if you write var somewhere in some program you're writing, it's not wrong. I will not tell you, oh my God, what did you do? But if you can try to use let, it's easier for you. When we create a variable, we can also put something inside it. We can create a variable without putting something inside it, like this. I have now created a box, but it's empty. There's nothing in there. It's undefined. There's nothing in there. I just said, here's a box. Or I can create a box and I can immediately put something inside by adding an equal sign behind it and then putting a variable value in. In this case, I take a string, my name, and I put it inside the box. The left side of this, we call declaring the variable. So creating the box where we are going to put something inside is called declaring the variable. And the right side, because we are giving it an initial value, we call it initializing the variable to this value. So after this code has run, the value of X will be equal to the string hello. After we've created a box or a variable, we can also read what's inside it, because of course, putting things inside a box and never looking what it's inside is not very useful. So after we created this box, we can see what is inside it. One way to see what's inside it is by printing it to the console. So if we do it and we run it, then we will see that here on line 19, we create a variable called X. X is initialized to the string hello. And on line 22, we say, hey, print X to the console. But in the console, it doesn't print X, but it prints the value of X. Notice that if I put quotes around it, I'll comment this for a second. If I put quotes around it, it just prints X. Whereas if I don't put quotes around it, it will print the value of X. So this is a typical mistake you might make in the future. You want to write the value of variable to a console, but if you put quotes around it, JavaScript just thinks you are writing the word X or the letter X. And you can also see the difference in color. When you put quotes around it, it's orangey or whatever color this is. And JavaScript just thinks it's the letter X. But if you don't put strings around it, it gets a white color, which means it's using the variable X. And even if you double click on it, you will see the other use cases of X. So now if I run it again, it will print hello, which is what we put in the box before. After we've created a box and after we've looked inside what's in our box by printing it to the console, we can also change what's in the box. How do we do that? We don't have to let anymore because we've already created a box. So the box exists, X exists, but we can assign it a new value. So again, we use these equal signs and we put the new value that we want to put in the variable on the right side. So after this line of code has run, the new value of X will be goodbye. So if you run it, then we see first that it prints hello, then we change X to goodbye, and then we print it again and we get goodbye. So we are using the same box. We didn't change to a new box. We didn't throw away the box. We just took the same box, same label on the outside, took out what's inside, put something new inside, and then we looked again what's inside the box.
So no need to write every time let before it.
That means create a new box. Whenever you have a variable or a box, just keep it. You can change it. Of course, when we write programs, we will use multiple variables to store multiple values, but it's possible to change what's inside the variable. And then there's one more tricky thing. We can change the variable by reading the variable and adding something to it. So if you look at this, actually what happens is the right side of the equal signs happens first. So the computer will look at the right side first. It will see what's inside the box, X. Then it will add this exclamation mark to it, and then it will put it back inside the variable. So remember, here we put goodbye inside X. So here, X is equal to goodbye. We add an exclamation mark, and we put it back into X. So X becomes goodbye with an exclamation. Any questions about this?
Equals to something like without any word like keyword like lab. Is it in JavaScript? Is it allowed as well?
So asking is like this?
No. I mean just X equals something. Is it allows allowed without for example string? Yeah, without the so in make a variable, create a variable without the word or the keyword like or var.
So here, and I would write it like this. And I run it. JavaScript will probably allow. So again, I haven't declared it, right? So you see it's allowed because JavaScript is flexible, but we don't consider it correct. And later down the line, it will give you problems. Also, the order is important. If I put this here, then I'm telling the computer, please give me the value of the box name. And then later I will tell you, hey, make a box name. If I run this, the computer will say, I cannot access name, the variable name, before initialization. So if you get something like this, it probably means that you're trying to use a variable that doesn't exist, that hasn't been created yet. So first you create a variable and then you start using it. Any other questions regarding this?
Is it the uppercase and lowercase sensitive, like the variable we cannot?
Yes. So if I do let name, is it different colors?
You started with the capital.
It doesn't like it. So go away. So you see, I create two variables, one name and one name, but written differently. And I print both of them, and you see they have two different values. So the casing does matter. However, when I'm writing code, I never think about casing. Why? Because all the programs will help you. Visual Studio Code, Study Lenses. So you see when I'm writing, I get autocomplete. So when I write console, I can just press top and I get it completed. I press log and then I open. And now if I start typing name, the first thing that pops up is the name of the variable. So I can just press top and it will take the exact spelling. So when you use especially longer names like list of students, please don't type it out completely like list of students, because then you make a mistake. You see, I didn't write it exactly the same as it was before, but instead just start typing and check the autocomplete and press enter or press stop, and it will autocomplete for you. Let the computer help you. Don't type it yourself because you will make mistakes. Any other questions regarding this? And then, oh, this is a screenshot. We will learn about trace tables. So maybe show your hand. Who has installed Study Lenses already correctly? 1, 2, 3, 4. Study Lenses. Did you install Study Lenses? I think Samir posted a video and it worked correctly. You could run it because we want to use it for some exercise, but if not everyone has it installed, maybe we do it after the break. So who doesn't have it installed? Can you raise your hand? You have a problem? 1, 2, 3, 4, 5. Okay, let's do the exercise after the break. During the break, we will come and check and help you with installing it, and then we can do the exercise in the 7 minutes after the break. I will show you the exercise already. So this tool is called Study Lenses. As I said in the beginning, it's one of the tools where we can write JavaScript. Once you are a real programmer, you will never use this again. This is only a tool helpful for learning. It has many useful buttons like run and table and highlights. But when you are a real programmer, you will probably use VS Code or something else. Why do we use this? One of the things it has, which is the exercise which we are going to do, is a trace table. So if we go to the first exercise and we click on table, we get this table thing that I can move around. And we can use it to try to follow what the computer is doing with the variables. So we start reading the program and we're trying to figure out what the computer is doing. First, we see this, but we remember this is a comment, so the computer will ignore it, so we can ignore it. And then it says, trace the program a few times with different values. On line 14, so here we write the line number, 14. We create a variable called x. And if we read it, we declare it and we initialize it. The left side is declare. Declare means we create a box, we create a variable, and the right side means initialize. So on line 14, variable x is declared and initialized to the value Peter. If you add plus, you get a second line. Line 15 and 16 are commented, so nothing happens there. On line 18, we have a variable called y, and it's assigned hello plus x. So what you would typically do is write y here, but remember what I said before, and it's quite tricky. The right side happens first. So actually the first thing that the computer does, again, variable x, and you write the name exactly here as it is in the program. If it's x here, you write x here. If you write uppercase, then you write x here. So first, the right side happens. So first, to make this new string, we are reading what's inside x, and we look in the trace table above. So we assigned Peter, so it's still Peter. And then on line 18, we have the variable y, and we declare and initialize y. So this is declare, this is initialize, and we declare it to what? Hello. Then on line 20, anyone have any idea? What's the name of the variable? Why? And what's the action we are doing on line 20? Out of these four, declare, initialize, read, or assign. Yes. So we are reading it. And to know the value of y on line 20, we don't look at the code anymore. We look at our trace table. Because this is what the computer is doing. It's keeping it in memory. So the last time we looked at y, we put it to hello Peter. So when we read it, it will be hello Peter. Line 22, what's the variable? X, because the right side happens first. What's the... Yes, and what's the value? Next one, 22. Y. So we are not declaring and initializing because there is no let. We already created a variable. It already exists. It's already in our trace table. So we are only assigning. And what's the new value? Goodbye. And the value of X, and X was Peter, so we put Peter. And then one more, line 24. Y. Read. Good. Is this clear? If we then open our console and we press this trace button, we get kind of the solution. The only problem is there's some junk in between. You can actually turn it off. Activate this and this. And then if we trace, there's still one more in there. Console. There we go. So now we can compare. So there's a bug with this table and sometimes it doesn't move. But now you can compare what is here in the output versus what we put in the table. The only difference between this trace and what you write in the table is that declare and initialize here is split up. But everything else should be exactly the same. So later when we are doing exercises, there are more exercises here exactly the same like doing the trace table. After the break, we will do it. You can compare your own solution with this by pressing the trace button. And you can compare what you wrote with this. If it doesn't match, maybe you forgot that the right side happens first. Maybe you made another mistake and we can look at it together. Okay, any questions about this? Okay. Let's see. When we are writing JavaScript, a lot of things will go wrong. Sometimes we will make a mistake. Sometimes our code will not work as we expected it to. It will do something, but not what we expect. For example, you think it will print something out of the printer, you press run, no errors, but nothing is coming out of the printer. And then, of course, we want to understand why. What's going on? Why is this not working? Sometimes JavaScript might tell you you made a mistake, and sometimes it will not tell you anything. And for this, we have many tools to figure out what's going on during the code. And the one we are going to look at today is the debugger in DevTools. So in your browser, Chrome or Edge, or even Firefox, you can either inspect element or you can press F12 and you get this screen. This one you're already familiar with from HTML, CSS, I think, where you can see the HTML and the CSS. This one we saw today prints out everything that we write console log will show up here. Some useful buttons here. This one clears it. So if you want to run something again, you can clear it. But then the next one we are going to looking at is this one, which is slightly more complex. I will pop it out so we have some more room. And then if I go to some code, so This is some JavaScript. First, we will look at it to see what it does, and then we will use the debugger. So here on line 16, we create a variable. The variable is called did click OK. And then we use something special, which is called confirm, which is inside your browser. It already exists. It's a function someone wrote for us, and we can just use it. And what it does is, if I run it, it gives us this pop-up. And the user can click OK or cancel. So whenever you use confirm, it will show a pop-up to the user with two buttons, OK or cancel. And whatever the user clicks will be put inside the variable. But instead of putting OK or cancel inside the variable, which is not very useful to work with, because maybe in a different language, it would be oui or non, or in Dutch, it would be something else. We put true or false, which is called a Boolean value. Remember, before we had strings, which is words, but we also have Booleans, and they have two values, true or false, which is equal to on or off, which is equal to correct or not correct. You can use it for whatever you want. And here it's used for OK and cancel. So if I press OK, then this value will be equal to true, because I clicked OK on confirm. It's assigned true. And then this code reads the variable and checks if it's equal to true. If so, it does this part of the code. If not, it does this part. We can actually do that with a debugger. So one of the buttons here, instead of running the code, I can click on debug the code. And this will open. And now I can go step by step through the code. So this is the sources tab inside of Chrome. It looks very similar in Firefox and Edge. You see the same code here. So it's still the same code. And there are some buttons here on the top right. The first one, if I click on it, it says resume script execution. If I click on it, the code will continue running and it will do exactly the same as pressing the run button. But there's another button here and it's called step over. And if I click on it, the computer will do the code step by step. So instead of running everything from top to bottom all at once, we can do step by step. So if I click one more time, I will get a pop-up here. Please click OK. I click OK. But the rest of the code has not run yet. We just only run line 21. So now we can do really cool things like hover over this and see what's inside this variable. And we see if we hover over it that it shows true. Also, we can see it here on the right. There is one variable called did click OK, and the value is equal to true. So it helps you to see what's going on step by step. Now here we have an if check. An if compares two values. It can be a variable and a value. It can be two values, or it can be two variables. You can compare anything you want. And so we are comparing this one with this one. If they are equal, then we will end up in the first part of this if. Everything in between these brackets will be run. If this is not true, we will end up in the second part of the if. So if we hover over this, we see that it's true. True is equal to true, so that is true. So we will end up in the first part. If I go to the next line, you will see that line 24 is the next line. And then if I go to the next line, it will not execute line 26 because it's an if, and it executes either line 24 or line 26. This is true, execute the first one, else execute the second. So let's see what happens if I debug and I press cancel. We're going to execute line 21. Nothing has happened here yet. It gives me a pop-up. I click on cancel. Now, if we look at the variable, it has false in it because I clicked on cancel. And so false is not equal to true. So it will execute line 26. Does that make sense? I know it can be a bit much or a bit confusing, but we use this tool to be able to go step by step over the code to get a better understanding. The things that you really have to understand is you can press debug and you will end up in the screen if you have it open. And you can hover over any variable to see the value. However, if I start the program again and I hover over this variable, it doesn't do anything. Why? Because it hasn't been created yet. We cannot see what's inside this variable as long as the computer has not created a variable. So if I hover over this, nothing happens. It doesn't exist yet. However, if I put something inside and I hover over it, it's true. Actually, you can do many freaky things like changing the value while the code is running. So right now it's true. I can change it to false, and now it's false. So actually, you can even modify your program while it's running to see how it would behave, or to change something, or to test something, or whatever. So maybe that's one thing I didn't show yet. This console window where we print everything from console log, we can just write JavaScript here. Just like we can write JavaScript in Visual Studio Code, we can write JavaScript in Study Lenses, we can write JavaScript here. So if I write that name is Jonathan, I don't see anything because I told the computer, create a variable name and put Jonathan inside. And the computer did that, but there is no output. But now if I write console log name, maybe it's because I'm debugging. Let's do that again. So I create a variable name and I print it, then the computer prints it. You can use this to try many different things really quickly without having to start a program or to run it. Whatever you type here is run instantly. As soon as I press enter, even before I press enter, the computer already shows you here what the output will be. Not always, but sometimes. So this can be very useful to try small things like what do you think will happen? We won't write it here, but what do you think will happen if I write this? What's the outcome of this in JavaScript? So some people think this. Does anyone think something else? Undefined? Could be possible. Someone else? It won't calculate. Okay, someone else? So let's try. So this is very easy to try this. And you get 1, 2, 3, 1, 2, 3. However, if you reverse it, it does it differently. Always. So JavaScript sees that you are adding two different things together. One is a number and one is a string. And it's like, well, it's really hard to add two things together that are not the same. You cannot do that. So it will try to help you and it will convert this number to a string. And then we remember, okay, two strings with a plus sign, it puts them together. But because JavaScript is so flexible, it tends to do some weird things. Like this one, it will add together as numbers, and then it will add it as string. And later it will become very problematic. Another thing that might be useful is what if we compare? So if we put 2 equal signs or 3 equal signs, like here, we are comparing two things with each other. So the result true is true because they are the same. One is not equal to true, so that's false. One is equal to 1, so that's true. So whenever we write if, we have to write something here that equals true or false. But JavaScript also has 2 equal signs. And you see it does exactly the same. 1, 2, false. So why do we use 3? Because JavaScript is so flexible, if I write this, they are not the same. One is a number, one is a string. Even though it both says 1, one is a number that you use for calculating, and one is a number that you use to print on paper or something like that. However, if I would use 2 equal signs, JavaScript says, no, they're the same. Why does it do that? Because, again, it sees, well, you're trying to compare 2 different things. Actually, that's not possible. I will help you. I will convert one of them to a string, and then they are the same. So by using 3 equal signs, we are telling JavaScript, we don't want you to help us. We don't want you to convert one of the 2 sides to another type to compare them. We know what we're doing. Don't help us. So always write 3 equal signs. Right?
Yeah.
Do you agree? It's one of the typical cases where you think your program might work, but then you get a very tricky bug because you are doing something that's not exactly working as you expected, and depending on the value, sometimes it works, sometimes it doesn't. So again, use 3 and your life will be much simpler.
So log name, you can also just write name.
Yes.
It's just like writing 1 + 1, it will just print out Jonathan. You don't have to always write console.
It only works. So it's very useful to, when you are debugging, again, if we go into this debugger view, and we step over the code. Now I lost my console here. How do we get it back? Here, there we go. If I go to the next line and I click on OK. So remember, you can see the value here. Remember, you can see the value here, and you can also just type it here and see it here. So right now, it might seem like, why would I use this screen? I can just use console log or whatever. But when your code gets more complex, when you have loops, when you have complex things like that, this one will be very easy because you can actually stop the code and go line by line. And maybe you expected that some value at some point will be something else than what is here. And then you can figure out what mistake you made. So let's do one more. Debug. So just to show you what mistake I made, when I don't have my console tools open, my inspector, and I press debug, it's actually the same as running it. Because we are telling the computer we want to debug these codes, but we don't have anything open where it can show us the line by line. So it's just running the codes. But if I open F12, or I do right-click inspect element, and now I have this open, and then I click debug, then it stops. Then it goes line by line. So if you are clicking debug and nothing is happening, or your code is just running, remember you have to open this screen first by clicking inspect element or F12. And then if you press debug, it will go line by line. So let's take a look at this code again. We create a variable, did click OK. We use this special function to open a pop-up, which shows true or false, OK or cancel. So I have to click it. I click on OK. So now we see one variable is created. It has a value true. And on the next line, we are creating a new variable, sorry. And the variable is called message, and the value is equal to an empty string. So it's a string, but it has no characters inside, so it's just an empty string. Again, we are going to compare did click OK with true. So which line are we going to end up, line 28 or line 30? If I execute the next line, will I end up on line 28 or line 30? Yes, did click OK is true. True is equal to true. So it will execute the first part of the if. And now you see it hasn't executed yet. The computer is waiting on line 28. And right now, the value of message is still empty string, because that's what we set it at on line 26. Now, after the computer executes line 28, you will see that the value is thank you, because we assign it the value thank you. Does that make sense? So first we initialize it to something else, then we assign it, and then the value in the box is changed. The empty string is just gone. The computer has thrown it away. It's not there anymore. We don't care about it anymore. And then the last line, alert, is very similar to console log, but instead of printing it to the console, it shows a pop-up with the string. So it's another way of showing something to the user. The difference is that if you use alert, every user will see it, whereas console log, you will only see it if you look at the console. Usually when you are using a website, nobody's looking at the console. You're just using Facebook or Instagram or whatever without opening the DevTools. But the alert will be seen by every user. So if I just run it as a normal user, I will get this alert. So actually, when you're writing real websites, we try not to use this as much. And if we use it, we actually make our own alert box, which looks way nicer with some colors and some nice text. This one is very basic, ugly, because it's made by the browser itself. So the thing you have to remember from this thing is that on the right side, you have this scope thing. And there you can keep track of, so it's under scope. If it's closed, you cannot see it. But if you open it, you see the different variables that are created. If you go line by line, you can see the value of each of the variables as they change. So now it's empty string, now it's thank you. So that's the scope screen on the right side here. The next one is hovering. I've actually already shown you that. Sure. Yes, you mean like the response of this button? So like here? Well, that's what this is doing, or I don't understand. This calls a function that gives us a button, and the response of this button is assigned to this variable. So when I run this, I get this pop-up. So confirm gives me this pop-up, right? And I have two buttons. If I press OK, this will return true, and it will give true inside our variable. If I press cancel, it will give false. So it can be true or false. And in JavaScript, true or false have special meaning. Yeah. I don't understand the question. Yes. True is a special value. Okay, good question. So let's go back to data types. The first data type we saw was a string, right? So you can write text in here, and we use this to print text. We can add it together like this, and we get one string. So we call this strings. And this is how we use it with double quotes or single quotes. Sorry. You can see I'm old because I'm used to writing double quotes instead of single quotes, but please write single quotes. Another data type is a number. It can be something like this, or even with a period to indicate decimals. And this is a number. And then the third data type we saw today was true or false. These are special words in JavaScript, and they are Boolean. Actually, there is a special word in JavaScript called type of, and it allows you to check what is the type of this value. So if I write hello, it will tell me it's a string. If I write 1, 2, 3, it will tell me it's a number. And if I write true, it will tell me it's a Boolean. Okay? So true is saved in the variable as true. It's a special value. And false is also a special. Does that answer your question? Not yet. It's okay. Okay, sure. Please don't be afraid to ask questions. I'm sure the questions are great. It's me not explaining it. So we were here on the hover. I think I already showed you, but I can show you again. I forgot to open the screen again. So remember, inspect, and then press debug. And then if we go line by line, again, we have a variable did click OK equals to the output of confirm. So I press OK. And then if I hover over it, we get true. If I hover over this one, it's not created yet. If I go to the next line, it's equal to empty string. This one is equal to true. And one thing that is cool is that if you select everything here and you hover over it, it shows you the value of everything. So this is a bit, oh, I can, yeah, I can show it in a better way. So let's run it again. And I click on cancel. So now did click OK is false, right? So now if we go to this line, if I hover over true, that doesn't do anything because it's not a variable. If I hover over did click OK, it shows me the value of the variable false. And then I can quickly check If I select everything like this, false is equal to true, no, so that's false. So by highlighting everything and hovering over it, I get the result of this comparison. It's the same as copy pasting this and putting it here, and I get the same result, false, but this is just quicker. So not only can you hover over the variables, but also simple comparisons like this, and you hover over it and you see the result of the whole comparison. Okay. The next one. Sometimes if your program gets very long, like if you have many different lines of codes, sure. If you have many lines of code, we don't want to go line by line by line, step, because if you have 1,000 lines, it's going to be very frustrating or very tiring. And there's many ways we can go directly to the line we want to go. Remember, the computer is still running the program from top to bottom, but we want it to stop at line 100. We don't want to click 100 times line. We want it to stop at 100. One way of doing this is to right-click on the line number and say continue to here. And so instead of saying run line by line, we tell the computer run every line and stop at this line. So we click continue to here. It will show us this pop-up, and then we stop at this line where we said. Okay. Now, if I run it again, and I would press continue, it hasn't stopped on this line anymore, because this continue thing is only once. And you can only do it when you're running. Right now, I'm not running, so I have to go run again. However, if you want to always stop on line 29, because you're really trying to fix this problem and you want to keep running your program over and over, there's another way to do it. Instead of continue to here, you can add a breakpoint. And a breakpoint means computer, stop here. Whenever you hit this line, stop here. So if I click on it, oh, that was the wrong button, sorry. Add breakpoint, you see that the line gets highlighted. So whenever this is the case, this means that if I run the code in debugger, not in running, if I run the code, it will not stop there, it's fine. Only if I press debug and I click start, break.
Let's go.
Oh, sorry, my mistake. It's because of this pop-up. Let's do that again because that was confusing. So I can right click here at breakpoint. For some reason, it's not highlighted correctly. Debug. There you go. So, and then you see there's a breakpoint. If I click on it again, I remove the breakpoint. So there's two ways to add it. You can just click on the line number, or you can do right click at breakpoint. If you have a breakpoint, you can actually see them normally. I think if I go on, no. I think it's study lenses that breaks this, if I remember correctly. When you are writing normal code in VS Code or whatever, you will see a list of all your breakpoints. Why is this useful? Sometimes you might have created like 20 of them, and you want to remove one of them, and you don't want to scroll through your whole file. There will be a list here of breakpoints that you have created. There's also another handy solution, which is remove breakpoint. And there's another one somewhere. Where is the delete all? Yeah, let's deactivate. Somewhere there's a button to delete all of them as well. I will have to find it. Keep in mind the breakpoints, they don't work if the line of code is not executed. So if I put my breakpoint here, if I put my breakpoint on line 32, I tell the computer, I want you to stop on line 32. Now let's debug, and let's see if the computer stops on line 32. I click OK, thank you. It never stopped on line 32. Why? Because line 32 was never executed. Because we have this if, and it says true or false, and it was true, so it executed line 30, and not line 32. Actually, that's a very useful feature because sometimes you want to investigate a certain bug and then you can put a breakpoint inside an if or inside an else, and you will only get there if something bad has happened or if you are in the special case. So use this instead of putting it here, use it where you really want to stop. And maybe I only want to stop when it's false if the users click cancel. So let's see that in action. If I click debug and I run the code, I get this pop-up, I click on cancel, and now the computer stops because now line 32 is executed and the breakpoint. Is that clear how you can put breakpoints, what they're useful for? So you can click continue to here. That's a one-time breakpoint. The computer will just run to code to there. You can add a breakpoint, or you can just click on this and it will add a break. This orangey line shows you what line the computer will execute next. So it's not the line that is just executed, it's the line that it's going to execute next. Breakpoints, we already covered. And then debugger is one more special case. It's another way of placing a breakpoint, and you see this special word here, debugger. Again, if I run the code, nothing special will happen. The code will run as normal. But if I run this code and I have my developer tools open, it's pop up, I click OK, and the code will stop on debugger. So actually, it's the same as placing a breakpoint, but instead of placing a breakpoint here, we are placing the breakpoint inside the JavaScript code. There is a big difference between them. Why? If Sophie and me are working in a team, whatever I do here is just me. If I click here and I put a breakpoint and blah, 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 this is only for me. My team doesn't notice anything. However, if I write this code and I send it to Sophie through Git or through some other way, and she runs my codes, her code will also stop here, which is usually not what you want, because it's very annoying. Usually it means that you were trying to find the problem and you were trying to chase it down, and you write debugger, so the code stops there. But when you found the problem, you forgot to remove this. So it's totally fine for you to use this. There is nothing wrong with this one or breakpoints. Some prefer one way, some prefer the other way. But if you use this, remember when you check in your code in Git, when you send it to your teacher, when you send it to your teammate, make sure to check for this. Because if someone else will try to run or debug your code, their code will stop running on this line. So it's like handing in your test when there's still like red and Tipex all over it. No, just get rid of it, because it doesn't change the code. It's only for you for testing. So you can use it, but remember, don't send it to your teammate. Don't put it in Git. Everything else is the same. It works exactly the same as a breakpoint. So if you click here or debugger, they work the same. Any questions about this whole panel? Breakpoints, debuggers? Questions? Okay. There are some exercises here. Trying to think. Because I think I wanted to do the other exercises first. So maybe let's take a break now. I know it's early, but I want to fix everyone's study lenses. And then we can do exercises after the break. So the people who have problems with their study lenses, please stay here and we will come around and help you. To make sure that your study lenses work, I will show you how it's supposed to work. So if you go to your welcome to JS folder, which I will paste for the ones who don't have it yet. This is the repository of the next two classes. I will put it here. So you are supposed to clone this somewhere. Once you have it cloned, so I have it here, I go to the folder, welcome to JS, and I type study. If everything is working correctly, of course, it's not going to work because it's already running. If I stop here, if I type study and I press enter, it should open your browser and you should see this screen. If you have that working, then your study lens is good to go. If that's not working, please stay here and we will come and check what the problem is. And then we have a 20-minute break. So it's clear for everyone. Earlier I said that when code is read, we do the right side first. However, if there are multiple variables like this, we still read left to right. So when I say right side first, yes, good job. No, it's okay. So if we have this line 22 here, it says we declare a variable C, and we are going to initialize it with this, the result of this, and JavaScript will go from left to right. So when I say right side first, I mean everything right of the equal signs. But after that, we still go left to right like normal English language. So if I would write line 22 by itself, I would get 22 A, read, and then whatever is in A, beta, I guess. And then line 22, B, read, Revit. So it's not the other way around. This will be important later. Now it doesn't really matter in what order they are read, but later when we start doing functions, you will see that the function on the left is run first and then the right. So everything is left to right, but when we are assigning, it's always the right side of the equal signs that happens first. So that's one good question I received. Another one is regarding data types. Some of you who have some familiarity with other programming languages might know concepts like this, where when you create a variable, you say what type it is. Maybe you say string text, or you say integer number or something like that. JavaScript has types. Remember when we showed the console, we can ask the type of any piece of value and it will tell us what type. But when you create a variable, it can have any type. So right now I put this in there and what is the name of type? The type of hello, it's a string. However, if later I assign a new value to hello and I put a number in there, and I ask what type it is, it's a number. So JavaScript allows you to change the data type of the variable. Most programming languages do not allow this. There's a good reason why they don't allow this, because it's really easy to make a mistake by changing data types. Later, when you're writing a program and you have a list of students and it has many names in there, suddenly you don't want to put a number in there. Like you want to prevent that from happening. JavaScript will just let it happen. It will not warn you. And then later, of course, your code will not work as you expected because you put a string or a number in something that you expected to be a list. Other languages, they will throw a compiler error or a runtime error, and they will tell you, whoa, what are you doing? You're trying to put a number inside of a list or a string inside of a number. JavaScript allows you. So that's what we mean. It's very flexible. Maybe even later down the line, you can use TypeScript, which is a special dialect of JavaScript, which prevents this again. But we will be learning JavaScript for now, which means it allows this. Usually when you're changing the type, you're doing something wrong. Like I cannot think of many good use cases when you're writing actual code that you want to change the type of variable. So keep that in mind when you create a variable, even if you are allowed to change its type and put a number in there, don't do it. It's only going to cause troubles. So that are the two things that I wanted to address. And then for the people who are almost finished with the exercises, there are more exercises about debugger, the thing that we saw here, where you can click on the variables and debugger and breakpoints. If you go to week 1, and then DevTools and debugger, isolate exercises. So right now we are inside week 1, computers and developers, tracing variables exercises. When you are finished with these 6, you can start on DevTools, debuggers, isolate exercises, and then inside these 3. Okay? Second.
And then
One more explanation, because some of you are having the same questions about 2 exercises. Exercise 5 and 6, you will see either an if statement or a while statement. Let's start with the if first. Everything I say, by the way, you can find it here in what is programming, and maybe not here, just enough JavaScript. So inside the repository, there is an explanation about comments and operators, Boolean strings, and also conditionals and while loops. So whatever I'm explaining now, you can read it yourself at home again under conditionals and while loops. But basically, maybe I will take it here. A conditional, like an if statement, always has something that it checks. Whatever is between the brackets, it will compare it to true or false. An if can only check if something is true or false. So if you want to check if a string is equal to something, you would have to write if hello is hello. These two together will make true or false, and then the if understands it. You cannot write here hello, because we are putting a string inside an if, and an if can only have true or false. JavaScript is very flexible, so JavaScript will not complain about this. It will say, you know what, I'm an if, I only know true and false. You give me a string, I will try to convert the string to a Boolean, and it will convert this Boolean to true, because JavaScript is weird and flexible. But this is wrong. We cannot do if hello. That doesn't make sense. It's not because it works in JavaScript that it's correct programming. And so after this check between the brackets, we open the curly braces, and we get a code block or a code statement. And this part of code doesn't have to be one line, it can be multiple lines. They will only be run by the computer if this was true. If this is false, it will completely skip this part, everything inside this block. So actually we can collapse it. It will ignore it because it was false. And it will go to the next line. And after an if, there can be three things. There can be nothing, like here, the if is finished. There can be an else if, which is another check, or there can be an else. If there's an else if, again, we are going to check, is this true or false? If it's true or false, if it's true, we go inside these curly braces and we execute it. If it's false, again, we skip over it. If everything is false up until this point and there is an else only, then that is what we do. If there is no else, like this, then we don't do anything. We just continue running the code without any special cases. Is that clear how an if works? So whatever inside has to be something that is true or false. So you can use equal signs to compare, not equal signs to compare the other way around. You can use less than, smaller than, less than or equal, bigger than or equal, smaller than or equal, etc. If you want to combine two things, like let's say you want to say if name is Jonathan and class, let's say teacher is Sophie, you can use this. So we are using two ampersands. If you want to say or, which is also possible, you use these two vertical lines. Again, everything I'm saying is explained here in these chapters under Just Enough JavaScript, so make sure to read them at home. But so this way you can make very long ifs and complex true, or, and, etc. So that's one. And then we have a while loop, which works very similar to an if condition. You can see one here. The beginning is the same. There's a keyword. Instead of if, there is while. We have something that evaluates the true or false. And then we have whatever is between the curly braces. If this is true, we go inside. If this is false, we just continue. However, the difference with if, after we are finished running what's inside, instead of continuing the rest of the code, because it's a while loop, we go back to the top. And we check again, is this true? And we keep checking if this is true until it's false. So what is the big risk? If you write something here that is always true, the most obvious case would be this. This code will keep running forever. It will never stop. even JavaScript is trying to help me by putting this in gray and saying unreachable code detected. Because whenever we reach this line, we will go back to this line and keep running over and over and over again. Of course, you will never write this, but it's very easy to write infinite loops. There is a button here, loop guard, which you can enable when you're working with loops. And if a loop runs more than 20 times, it will stop. Because the programs we are writing should not run more than 20 times. So it's assuming that you wrote an infinite loop by accident. That's totally okay. It's normal. Everyone writes an infinite loop. It's sometimes funny. If you don't do this and you run, your browser will freeze. Because it keeps running forever and ever, and you cannot stop it unless you kill the browser or kill the tab. So make sure this one is enabled when you're working with loops and you're running the code or debugging it or whatever. So very similar to an if statement, you have a keyword, while. It checks if this is true or false. If it's true, it executes this, and it goes back to the top and checks again if it's true or false. If it's false, it exits and continues the code. Any questions about these if conditions or while loops? No? Okay, then you should be able to make the rest of the exercises. Let's wrap up these exercises. How did it go for everyone? Was it hard? Was it medium?
The concept of
You have a question? For the first exercises or for the debugger? Okay, let's do it together. This one? Okay. The first one or the second one? Only have time for one. Yes. Okay, so oh, you have a problem with the challenge? Okay. Well, let's first look at the program and see what it does. We create a variable input and we initialize it to 0 to annual. I wanted to talk about this. This is a special value in JavaScript. We have numbers, we have strings, we have booleans, and we have this special value called null, which actually means it's an empty value. It's not the same as an empty string. An empty string is a string and behaves like a string. I can ask what is the length of this. I can add it together with other strings, etc. It's just a string with nothing in there. Null actually means there is no value. Why is this useful? Let's say you have someone who asks, where you ask someone a question like, is married, right? And this can be true or false, right? It can be true or it can be false. But if we have this, we want to have this information for someone, but we haven't asked him the question yet, we might put it to null, meaning we don't know it yet. Eventually it will be true or false, but right now we haven't been able to ask him. He hasn't completed the form. So it might start as NLL, and then when he answers it, it might become true or false. So sometimes it's used as an initial value like here, because we are going to ask someone something, but we start with this value being NLL. Any data type can be NLL. So a string can be NLL, a number can be NLL, a boolean can be null, etc. Is that clear what that null is? JavaScript is a bit tricky. It also has another special value called undefined. I think if you do this, I will do it in the console. If I create a variable let name and I check the value of name, it's undefined, which means I haven't put anything inside there yet. Whereas if I do let name is null, and I check the value, it's null. In JavaScript, there are two different things. In a lot of other programming languages, they are the same, meaning if you don't put a value inside a variable, it's null. For some reason, JavaScript has two kinds of empty values. One, undefined, means you haven't put anything inside there, and null means you put something inside there, but you don't know the answer yet. With that being said, this is a while loop. So if this is true, we will go inside the while loop. If this is false, we will not go inside the while loop. Input is equal to null because we have declared initialize it to null. So we go inside the while loop. And inside the while loop, we do a prompt. So if I run it, we get a prompt. And whatever I type here will be assigned to the input variable. So I say hello HYF, and then it says thank you, and the program stops. However, if I run it and I click on cancel, this prompt function will tell me he did not enter anything. He click cancel, and it will return null from the prompt. Input will be equal to null. We assign it null. We go back to the while loop. Input is equal to null, and we will run again. So whenever I click on cancel, it will keep going forever until I enter something. You will see this pattern in future exercises just to make sure that someone enters something. So a lot of exercises might start with this to make sure that you don't press cancel, that you know that after we continue, we have some string. So I can type something and it stops. And then here it says, try to create an infinite loop so the user gets stuck inside your prompt. You can do anything. There's many ways you can do it. You can do this. Then it's an infinite loop. You can not assign it.
If I keep canceling it, I'm in the
Yeah, but an infinite loop means actually not being able to get out of it. So let's say I don't assign it to input. Well, input is never changing, so it will always be null. So the loop will keep going, etc. So does that answer your question about the challenge? Okay. Anyone else? How did the exercises go? Was it hard? Do you have any questions still? Sure. So remember to be able to put breakpoints or see the debugger, we have to open the DevTools, F12 for inspect elements. Then we go to the sources tab, and then we can just press the debug button here. And this is something specifically to study lenses. It adds this magic debugger at the top, which is why it stops running the code. Later, when you're programming yourself without study lenses, there is no debug button, and you will have to go yourself to sources and put a breakpoint on. So let's say I want to stop right before it gives me the pop-up thank you. There are many ways I can do it. I can do right-click, continue to here, and the code will keep running until that line. I can click on add breakpoint, and then every time I run this code, it will stop on that breakpoint. Or I can click on this line and it will highlight it as a break. So you can ignore them for now. So exceptions are things that happen in your code that are unexpected, that you made a mistake or something went wrong. Something went wrong can be like you want to download a file, but the file doesn't exist or something like that. And these buttons then allow you to stop there. So if something happens, you can check what's going on. The problem with JavaScript is if you enable this, it might stop on a lot of cases. That's why there are two different ones, caught and uncaught. Caught is basically something might go wrong, but I expected it, so keep running. And uncaught means something went wrong and I didn't expect it, so only stop there. That's what they are for, but we will maybe use them later. So I now put this breakpoint on alert. So if I press this button, which keeps running all the codes, I will get a pop-up. I type some text. Now the breakpoint comes right before that the pop-up is shown. If I go to the next line, we get a pop-up in the back. Okay, and then the code can come. Any other questions? No? Okay. Something I want to really emphasize, and it might sound boring or it might sound, sure, let him talk. We are learning a new language. JavaScript is a new programming language, but you can compare it to learning a new language. I think everyone in the room here speaks more than one language. So we know how hard it is to learn a second language or a third language. You need to practice it every day. And of course, every day is idealistic, but this will not work if you now go home, you close your laptop and you come back on Sunday and you expect to remember everything. It's not going to work. Maybe next week you might still be able to get by, but in 2 weeks you'll be like, what the hell is going on? I don't remember this, whatever. So when you get home, Monday, Tuesday, Wednesday, open your laptop, 10, 15 minutes, look at the different modules, read the theory, maybe do an exercise again, maybe try writing some JavaScript already yourself. We will do more later in next week, but don't let this sit for a week because you will regret it and you will not be able to keep up. And unfortunately, we have a lot of material to cover for only 5 weeks to get the basics of JavaScript. I have to make a choice. If there are some people in class struggling and I put too much time in them, then everyone else is not getting all the information they need. And if I give everyone else the information they need, the people who are struggling will not be able to keep up. So put some time in it at home. And when you have questions, ask me, ask Sophie, ask them in Slack. Maybe not now yet, but next week and the week after, I will maybe organize a session during the week where you can where I will answer some questions or look at some exercises or mistakes you have, probably on a Wednesday or a Thursday. But at the same time, I expect from you that you put some time into learning this, because it will not work when you just come back on Sunday and not look at it. I think there was one more thing I wanted to say, but I wrote it down. We covered null. Okay. I'm sorry? Yes, so it changed a bit because the lesson plan changed a bit. Let me check. So these are lesson plans. So next week we will cover week 2. But the theory here, what is programming, is a bit about where you can write JavaScript and how computers work, etc. You can read over it, definitely. The most important one is this one. And it teaches you the basics of JavaScript. So it's only theory. There's not many exercises, I think. I will double check, but there's no exercises here. It teaches you about operators, booleans, ifs, null, numbers, etc. Ideally, you have read all of this by next week. So all of these 17 chapters. For the people who want more challenge or for where it's too easy, there is a lot of stuff under suggested study. So different sites you can use, different exercises, etc. When you are writing JavaScript, things have changed since the last few years. We all know AI exists and maybe some of us use it. Whatever we are learning here, the AI will be able to answer it perfectly. So if you have a question, if you have some code and you have an error and you put it together in the AI, it will tell you perfectly what you did wrong, how to fix it, etc. Use that. It will answer exactly the same as what I would answer. So either use the free version of ChatGPT, or Bing also has a free version, I think, or maybe some other AI that I don't know about. Use it, put some code in there, put your error in there, or ask a question. Why is this null? Why is this not working? Why does line X do this? And it will give you the answer. If the AI still can't figure it out, put it in Slack or send us a message and we'll try to figure it out. But use these tools. It's super handy. If I look at how I write code now versus 2 years ago, I think 30 to 40% of my code is now being done by AI. So the faster you start learning these tools by helping you debug or by autocomplete or stuff like that, the better it is for you and your career. Of course, we need to learn the basics to be able to understand what AI is doing for us, or to see when the AI makes a mistake, because it's still not perfect. But don't be afraid to use it to answer simple questions and stuff like that. So there's no exercises you have to make. There's no things you have to do. If you haven't finished the exercise from this week, finish all these tracing ones. And also under DevTools, there's some more, which you can take a look at. But these are already quite advanced. If I go to this one, it's not working. You can skip this one because, so for DevTools, only look at isolate. And the goal here is to be able to use these tools, step over breakpoints, etc. And also there is always a challenge here at the bottom. So try and see if you can make it work. Usually it means changing some part in the code, like changing this to 10 and seeing how that affects the code, run it again, etc. So try those. Okay. Any questions, any comments before we wrap up the class? Okay, that's it. Thank you, everyone. Hard?
No, you-